Hello everyone, welcome back. In previous lecture, I started the new subject that is about the manufacturing processes, and I also discussed about the GTU syllabus and brief classification about the various manufacturing processes. Now, in today's lecture, I am going to explain about what is machine tool and how the classification of machine tool is done and what are the various types of motions in machining. Okay, so let us start. So the first thing, that is the what is the meaning of machine tool. So a machine tool is a power driven device which energy is utilized in deformation of material for shaping, sizing, or processing a product to a desired accuracy by removing the excess material in form of chips. So what happens in a machining process? So it is a power driven device in which the energy is utilized in deformation of material, in which the material gets deformed. So in form of shaping, sizing, or processing a product in a desired accuracy. Accuracy means the closer to the our required dimension by removing the excess material in form of chips. So it is basically material removal process, you can say. Okay, now the machine tools are generally used for two purposes. The first purpose is to produce certain form. Okay, suppose we want to make a specific form, then the machining will be required. Okay, suppose you want to make a nut bolt. Okay, or suppose you want to provide thread to okay, so machining will be required. Suppose you want to perform knurling operation, then second thing is to produce finished surfaces like any object that requires the finished machining. So the for finishing also we require machine tools. The form of surfaces produced depends upon the shape of cutting tool and relative path of motion between cutter and वर्कपीस. ओके, सो यहाँ पे क्या होगा कि जो भी फॉर्म हम क्रिएट करना चाहते हैं सरफेस का, ठीक है, प्रोड्यूस्ड डिपेंड अपॉन द शेप ऑफ कटिंग टूल का शेप कैसा है, ठीक है, what kind of shape it is and relative path between cutter and workpiece. Suppose this is our okay, wait a minute. So suppose there is a workpiece. Suppose this is our one piece of shaft and that is to be machined. Okay, so with the help of cutting tools, suppose this is our single point cutting tool. Okay, so we are supposed to reduce the diameter of this by machining in, suppose the machining is done in this direction, the diameter of this will be reduced. Okay, so in machining the form produced depend upon the shape of cutting tool and relative path of motion between the cutter and workpiece. What is the relative path between cutter and workpiece? So the relative motion, also known as working motion. सो यहाँ पे जो रिलेटिव मोशन है, द वर्क पीस विल बी इन रोटेटिंग, ओके, motion, while the tool will be in translate or linear motion, okay, between cutter and workpiece, can be obtained either by workpiece or cutting tool or by combination of both. So sometimes the combined motion is also there, which means the workpiece can, here it can, the cutting tool can travel in this direction as well or in this direction as well. Also it is supposed to rotate as well, okay. So this is about the brief and about the machine tool. Now the working motion are of two types: primary cutting motion, that is called as dry motion, and second one is the feed motion. So in the example I shown, the primary cutting motion was the dry motion, and the feed motion was the primary motion was provided to the workpiece, and the feed motion was provided to the cutting tool. So this is the shaft after we cut it. So this is our tool, and the shaft, the primary motion is given to this, okay, and the tool will be having the feed motion, which means it will be traveling, and the working motions are powered by external source of energy. In addition to working motion, auxiliary motions such as clamping, unclamping of workpiece, tool holders, idle travel, changing speed, or engaging, disengaging of working motions are also provided on machine tools. So these are also provided on the machine tool as well as, okay. So the primary motions, that are the drive motion, they are from the एक्सटर्नल पावर सोर्स, जो टूल को हम क्लैम्प करेंगे, अनक्लैम्प करेंगे, ठीक है, फिर वर्कपीस को क्लैम्प करना, अनक्लैम्प करना, और ये सारी जो आइडियल ट्रैवल है, चेंजिंग स्पीड कैन सी, एंगेजिंग, डिसएंगेजिंग ऑफ वर्किंग, are also provided to the machine tool. Now the next is classification of machine tools. So the general classification is based on, the first one is the purpose of application. What kind of application is there? So first one is the general purpose machine tools. For example, lathe, shaper, milling machine. These are used for general application, which performs the general operations. Okay, and the second one is the special purpose, that are made for only one particular operation, such as gear hobbing. So gear hobbing machine can only produce gears, okay, it can cut only gears, so that will be the special purpose machine tool. Another type is type of motion, which means reciprocating type, and second one is the rotary type. What kind of motion is there in shaper machine? There will be shaper, planer, slaughter, there will be only reciprocating type of motion of the tool, while in other there will be rotary motion, and sometimes the combination is also there, like in lathe drilling there will be rotary motion of workpiece, okay. In drilling machine the tool will be rotating, and in grinding the cutter will be rotating. Okay. Now, type of surface produced. Another classification, type of surface produced, in which the first one is the production of cylindrical surface like lathe and drilling, and second one is production of flat surfaces. For machining of flat surfaces, there are milling machines and shaper machines. Another is degree of automation, in which manual control machine tools, semi automatic machine tools, and automatic machine tools. Now, the lathe machines are usually manual control machine tools. Okay, then there is drilling, milling, shaper, planner. Also, there is automation is also there, but they are usually manually controlled machine tools. And in semi-automatic, there is turret and capstan lathe, in which the multiple tools can be mounted. And another is automatic, that is parallel and progressive axis machine automates transfer line machines. Okay, so these are the automatic machine tools. Another type of classification is type of energy source which used by the machine tool. So first one is conventional machine tool like lathe, drilling, milling, shaper, and second one is non-conventional machine tool. For example, there are the electric discharge machining, electric chemical machining, ultrasonic machining, then abrasive jet machining, abrasive water machining. So this comes in the category of non-conventional machine tools. Another type of classification is based on cutting tool used. What cutting tool we are supposed to use, like single point cutting tool, for example, lathe, shaper, planer, okay, slaughter. These are the single point cutting tool. In lathe, we use single point. In shaper, planer, slaughter, while another is multi-point cutting tool. In multi-point cutting tool, there is milling machine, in which the multiple points of the cutter comes in contact with the workpiece to remove the material, like milling, drilling, and grinding. So these are the multi-point cutting tool. Now this was the general classification. You can remember this, and this is very important. Okay, to know from the exam point of view as well. Okay, now we will go further detail in this. So further classification, if we go on, so according to type of surface generated, as we discussed, that is cylindrical, and in there you can see this is the lathe machine. First one is the lathe, and second one is the grinding. You can check out over here that there is the flat surface is produced, sorry, cylindrical surface is produced in the both of the form. And you can see the workpiece is rotated about axis, and workpiece may rest, and tool is rotating either of the position. Here in lathe machine, the workpiece is rotating while the tool is stationary, while in grinding the tool is rotating and the workpiece is also rotating. So both of this can be possible, like such various types of works are produced on the lathe, turret, capstan, boring. Okay, the cylindrical surface. Another type is, as I discussed earlier, that was about the flat surfaces, and the flat surfaces are produced here. It is in the shaper, then there is the milling, and last one is the drilling operation. So here you can read about the how the generating of the plane surface, as the workpiece is moved past the cutting tool, a straight path. The tool is transferred in perpendicular direction, or alternatively tool is moved in straight path and workpiece is transferred in perpendicular direction. In both cases, the tool or workpiece is transferred in perpendicular direction only after one cut has completed. The machine doing this type of operation are planer, shaper, and slaughter or broaching. So here इन दिस फिगर यू कैन सी दैट द शेपर, यहाँ पे शेपर मशीन में क्या होगा कि जो टूल है वो रेसिप्रोकेट करेगा, साथ ही में जो फीड मोशन है वो वर्कपीस को दी जाएगी, ठीक है। यानी कि एक कटिंग स्ट्रोक जब कंप्लीट होगा तब ये वर्कपीस मूव होगा स्लाइटली, देन सेकंड cutting stroke will be performed. And in the flat surfaces could also be produced by having rotary motion of multi-cutting edge tool and translatory motion of job. So the example of machines employed such as milling, surface grinder. So here in milling machine also the flat surface can be produced. Here you can see that the flat surfaces are also produced using milling cutter. ये जो milling cutter है ये rotate होगा, और जो flat surface है और वो यहाँ पे फीड मोशन हम उसको भी प्रोवाइड कर सकते हैं, या फिर वो स्टेशनरी है और ये कटर जो है वो रोटेट भी हो रहा है और मूव भी हो रहा है, ठीक है। सो यहाँ पे ये जो है, यहाँ पे ये कटर जो है ये सिर्फ यहाँ पे रोटेट हो रहा है, ये मूव नहीं हो रहा है, यहाँ पे वर्क पीस मूव रहा है। अनदर टाइप्स ऑफ मिलिंग कटर्स दैट आर हॉरिजॉन्टल मिलिंग कटर्स, ओके। इन लेटर ऑन वी विल डिस्कस व्हाट इज अप मिलिंग, डाउन मिलिंग, ओके। एंड with drilling, as we know, holes are produced. Another type, according to type of surface generated, there was for lathe and boring. As I discussed here, the specifically I have written what is the dry motion and feed motion. So dry motion is of workpiece, okay. Rotary motion, this is called as dry because the from chuck here it is connected with the power or motor, and the drive motion, which means the cutting force actually, that is the rotation is provided to the workpiece, okay. While the tool is stationary but it is traveling, only the feed motion is provided, which means the this direction linear motion or axial or radial, this is the radial direction and this is the axial direction of in the axis, okay. So two types of motion, dry motion and feed motion. So for lathe there or boring machine, the dry motion is rotary to workpiece while feed motion is to the cutting tool. And for drilling machine, here you can see the drilling machine, the drive and feed motion both are provided to the rotary drill, and the feed motion is also provided to the drill. While in milling machine, you can see that the rotary motion is provided or the dry motion is provided to the cutter, okay, and the feed motion is provided to the वर्कपीस। जो फीड मोशन है वो यहाँ पे वर्कपीस को प्रोवाइड की जाएगी, जबकि ड्राई मोशन जो है वो कटर को प्रोवाइड की जाएगी। अनदर इज फॉर शेपर, प्लानर एंड स्लॉटर। एज यू कैन सी द शेपर, यहाँ पे जो फीड मोशन है, ठीक है, फीड मोशन वो यहाँ पे वर्कपीस को दी जाएगी, जबकि जो ड्राई मोशन है, द कटिंग एक्चुअल कटिंग फोर्स that will be produced by the tool itself, because the force will be given to this. So dry motion is the reciprocating motion of cutting tool, while the feed motion is of workpiece. And for grinding machine, here you can see this is the grinding. So the drive motion is rotary motion to the grinding wheel, and the feed motion is rotary as well as translatory motion of the workpiece, okay. Sometimes it remains stationary. Another way of classification that is general purpose that I discussed already. Then there is production machines tools, okay. So the production machine tool, that was the special purpose, okay. uh, that or production we can say, that is for the, that is the capstan lathe or turret semi automatic, okay. This comes in the production. Then there is special purpose. In special purpose, these are used for mass production, like I discussed earlier, okay. Suppose the gear generator, camshaft grinders, piston turning lathe, then thread rolling machines, okay. Then the surface finish produced depend upon the feed of the tool or workpiece. Then various machines are capable of producing different types of finish. In the increasing order of good surface finish, various operations used for machining are arranged as these are the various machining operations such as cutting, okay, showing, hand grinding, filing, turning, shaping, milling, boring, drilling, surface grinding, cylindrical grinding, boring, lapping, polishing, or surface finishing and buffing. So increasing order of good surface finish. So in cutting we will get the least surface finish, while in buffing we will get the highest surface finish. The important requirement is to be fulfilled by the any machine tool is that it should be able to produce jobs with high degree of accuracy consistently over long period of time. For this, it is essential that they possess static as well as dynamic rigidity. Rigidity of machine tool is its capability to resist deformation produced due to introduction of cutting force generated while machining. कोई भी मशीन है वो कितना रिजिड है, वो कैसे पता चलेगा कि उसकी कैपेबिलिटी क्या है कि वो डिफॉर्मेशन को कितना रेजिस्ट करेगा, ठीक है, व्हेन द कटिंग फोर्सेस आर इंट्रोड्यूस्ड. And another classification is the flexible manufacturing systems. These are the latest machines which can be used for the. So here these are the latest machine tools which can be used to machine any job, and these are the designed to achieve following objective. So first one is the less machining time per part, reduced loading, tool changing and other non-cutting time, more flexibility, greater compa- compatibility with the system, reduced operation involvement, improved safety, less noise. These mainly employed machining centers, very versatile like machines and robots for material handling. Then machine tool can be classified into several other ways as per the weight, as light duty up to 1 ton, then medium duty up to 10 ton, or heavy duty more than 10 ton. As per the degree of automation, as manual or semi-automatic or automatic machine tools. The process of chip removal is affected by the relative motion between tool and workpiece. The motion of machine tool may be transmitted either to cutting tool or to the work, or both simultaneously. Okay. Now the working motions of machine tools are primary cutting motion as I discussed, and then there is feed motion, that is called as speed or feed rate. In primary cutting motion, it provides for cutting tools the cutting cheap from the blank. The most commonly used type of primary cutting motions are rotary primary cutting motions and reciprocating cutting motions. In rotary primary cutting motions, these are the various machines. Here it is the lathe machine, then there is grinder, this is the drilling machine and milling machine. These are primarily refers to the primary cutting motion, or that is the rotary type of. Here you can see there is rotary motion in the grinder, in the lathe, and there is in the drilling and in the milling. Okay. So as I discussed, this is here you can see. Then there is reciprocating primary cutting motion. For reciprocating, this is the shaper machine, this is the planer machine, and this is the slaughter machine. Here you can create slots in the workpiece. Okay. In the planer, the table will be reciprocating with a V1, or this is the V1, this is the forward stroke velocity, and this is the return stroke velocity V2. Same here V1, the forward stroke and return stroke. And here the tool remains stationary. In planar machine, the tool will be stationary while the platform will be traveling. And in the shaper machine, the platform will be only having the feed motion. Okay, perpendicular feed motion, and while the cutting action will be done by this cutting tool. Okay, so here you can read what I said. Okay, another, that is the feed motion. So the feed motion enables the cutting process to be extended to the whole surface to be machined on workpiece. The rate of feed is sustainably or less than the cutting speed, substantially less than the cutting speed, and other condition being equal to the rate of feed determines the क्रॉस सेक्शन एरिया ऑफ द चिप. जो फीड है, ठीक है, वो कटिंग स्पीड से कम ही होगी. A machine tool is subjected in addition to its static load to dynamic load due to reciprocating and rotary motion, cutting forces and friction forces. जो फोर्सेस है वो एंड में हम डिस्कस करेंगे कि कौन कौन से चैप्टर के एंड में आएगा टॉपिक कटिंग फोर्सेस, वो हम डिस्कस करेंगे. वाइल कटिंग कितने फोर्सेस लग रहे हैं. और जो फीड मोशन है कैन बी एक्सप्रेस्ड एज फीड पर revolution or feed per stroke. The feed motion is, remember this, feed per stroke or feed per revolution, feed per teeth. Here it is given, for example, there is the cutting speed for rotary primary cutting motion is expressed as meter per minute. Pi d diameter of the workpiece, then rotate rpm, that is the n, pi dn by 1000. So we can calculate the cutting speed for primary cutting motion. While for tools with the reciprocating cutting motion, the cutting speed is calculated in length of stroke in mm divided by 1000 into type of cutting stroke in minute. Okay, यानी कि कितनी लेंथ है कटिंग स्ट्रोक की, लेंथ ऑफ स्ट्रोक डिवाइडेड बाय 1000 इंटू टाइम ऑफ कटिंग स्ट्रोक, कितना टाइम हमने कटिंग किया. ठीक है, सो ऐसे हम कैलकुलेट कर सकते हैं कि कटिंग स्पीड कितनी है. ठीक है, कोई भी रोटरी कटिंग मोशन के लिए और रेसिप्रोकेटिंग कटिंग मोशन के लिए. So this is it for today's lecture. Thank you very much for listening me carefully. Have a nice day.